AlCl4 minus will lie in close vicinity. AlCl4 minus will lie in close vicinity, and it's these ions which are responsible for the color. This positive and this AlCl4 minus in vicinity is responsible for the color and the conducting nature of the solution, because only with DCl and AlCl3 we're never able to create that solution. Now the small difference between the mechanism proposed before and now is we're considering DCl and AlCl3 to react independently, and then we're considering AlCl3 to generate an electrophile which is going to attack the ring in a different step. As a matter of fact, that's going to serve most of the requirements. That is what you're supposed to write in most of the exams. But I repeat, a more detailed study will reveal the following. First of all, it's going to form a weak pi complex with the ring. Because of AlCl3, it's going to mature to a sigma complex. In absence of AlCl3, it doesn't mature. Now, because in absence of AlCl3, it doesn't mature to a sigma complex, this deuterium with carbon forms a weak bond only, and carbon deuterium never got converted to carbon. Carbon deuterium was never formed from carbon hydrogen. I hope you're getting me. In absence of AlCl3, this pi complex didn't mature to the sigma complex, and carbon hydrogen getting converted to carbon deuterium never happened. Fine. Whereas in presence of AlCl3, which actually acts upon the pi complex and not upon the molecule itself, what happens is it draws Cl minus towards itself, so still it's acting as a Lewis acid, but it's a collection of these many ions, these many particles together, which is responsible for the actual solution which is formed. Now this gives you the sigma complex, but not before a pi complex is formed. AlCl3 always helps in, or only helps in, maturing this pi complex to a sigma complex. Yes, this AlCl4 minus also plays a role. AlCl4 minus also plays a role in taking out H plus. Now this has to lose H plus. If it loses H plus, it becomes aromatic again. AlCl4 minus might be playing a role here, because AlCl4 minus will help in the loss of H plus. This H plus will interact with AlCl4 minus, forming AlCl3 and HCl. HCl is going to be the byproduct of the process, and AlCl3 will get recycled. So AlCl3 acts as a Lewis acid. AlCl3 acts as a catalyst because it's getting regenerated. This is going to be the real story. A pi complex maturing to a sigma complex, AlCl4 minus helping in the abstraction of H plus here, making it aromatic again. H plus interacting with AlCl4 minus, regenerating AlCl3, which is acting as a catalyst, and HCl is formed as a byproduct. Now again, it's still going to ask for the same energy profile, because this will be the slow step this time, and this loss of H plus is going to be the fast step. It's going to call for the same energy profile, which is going to be the general energy profile for most of the aromatic reactions. It might get a little remodeled in case of individual reactions. Fair enough? And now I can explain now. I can explain now a ring interacting with a pi bond. A ring interacting with a pi bond, or a molecule like this. And in this weak association, now AlCl3 plays a role. Now AlCl3 pulls it towards itself. Because AlCl3 has to work upon a complex and not upon an individual atom, the role played by AlCl3 will not be limited to halogen only. Because now it's polarizing this bond towards itself, letting a pi complex mature to a sigma complex. It's staying in the vicinity of this ion, it's getting detached only once it takes away H plus with it. I repeat, now because we know it's acting upon a complex and not upon a given molecule, its act will not be will be limited to a chlorine or HCl or DCl or RCl or RCOCl or halides or bromides. It can act upon any pi complex. Fair enough? And once it matures to a pi complex, a CH is going to be changed to a C. Now, just go through all of this. Let me know if you have any serious issue with this, and then we might take up a few actual reactions. We might talk of some common reactions, electrophilic substitution reactions. A small break, and then we resume.